my topic was about the uses of digital twin. It's what it can do and how it's currently used in the current industry. So I'll start. So in, Industry 4.0 means it's a fourth industrial revolution. This concept was first presented at Hannover in Germany in 2011. This The Industry 4.0 was actually the main focus behind it was to reduce the production cost by 10 logistic cost and quality management cost and increase the efficiency. The main technology which triggered the fourth industrial revolution was information and communication technologies, uh, and it's preceded by three industrial revolutions, which have its own characteristics and their own drives and enablers. I have shown in it this diagram. So in 1980s, the in first revolution, it brought transition from manufacturing from manual labor to mechanization. In second revolution was triggered through introducing electrification, which enabled mass production and industrialization. In third industrial revolution was triggered by digitalization and electronic automation, and now it's currently the fourth automation. It's still ongoing. It's not yet finished, and this is the only industrial revolution which is happening when the people know that it's currently happening. It brought forth smart automation and cyber physical production systems. So
Yes, can you quickly go to your findings rather than the actual theories?
Yes. So we know what is digital twin. Digital twin is a complex, high probabilistic and high fidelity virtual simulation. It's different from a normal digital model which is used for CAD. A digital twin is different in this way that a digital model is just a model. We can apply various processes to it, but a digital twin is the actual replica of a physical system. I've shown in this models diagrams. So in digital model, the data which is fed in the system is through manual mode, and in digital twin it's there is auto data flow, so that when a physical system is operated, the digital twin is also operated, and vice versa. If a digital twin is operated, so is the physical system operated. So here I have shown how a digital twin works. So first, various data is gathered through the use of sensors, and it is saved and transferred through the cloud and other network communications. Mainly we use 4G and 5G communication for data transfer, because it is very fast. So then the data is analyzed and the model is made, and it's simulated. So the various data is then passed through the AI based algorithms and integrated into physics based virtual model. After applying to this model, we get the relevant digital twin. So as I've said, the main things which are needed for the actualization of a digital twin are sensors and actuators to transfer and get the data from a physical system, and data analytics to evaluate and simulate the model. So digital twin is actually a multi-layered model. Uh, Here it has a 5 layers: physical space layer, uh, network and communication layer, virtual space layer, data visualization, and application cloud layer. So in the physical space layer, it's a main building block of digital twin. It consists of physical objects, sensors, and single signal conditioning unit, and other physical units like power driving circuits, actuators, etc. The primary focus of this layer is connection and authorization to the high speed CPUs, so that it can simulate the model. So next is communication network layer. The purpose of this layer is to transmit and receive the data gained from sensors, actuators, etc. This communication technologies used here are 4G and 5G, as I've said. The virtual space layer. This is mainly divided into data aggregation layer and data modeling. The data aggregation layer collects in-network sensor data from respected sensors and communicated through this layer for further storage and processing. It involves the gathering of operational and environmental data sensor received. The data modeling is used to construct a dynamic 3D models of a physical system, which is being monitored, of which a digital twin is to be made. The data read and used to construct the model it's a real-time data transfer. So as the current state of a physical model is reflected in the simulation. Data analytics and visualization layer. This layer accesses the data repositories to take the data and report results to the management. The aim of this process is to assess the condition of the physical object or system and predicting its possible failures and maintenance requirements for the upcoming future. This layer has two important tasks: complex tasks that include data cleaning and processing. It involves like smoothing, discretization, feature extraction, data reduction, etc. And second important task is to supervise machine learning using classification and regression techniques on sensor data. Next is application cloud layer. The large amount of data sent to virtual space digital twin is essential in manufacturing process. This data can be turned into actionable insights with the help of manufacturing business intelligence tools and techniques that record all the activity for each machinery component and sensor. I've shown here a diagram of the 5 layers. We have identified a few areas in manufacturing and production in industry where a digital twin can be used. So first is production planning and control. So digital twin is here to use for planning, scheduling, routing the production, and loading, etc. And for its digital twin can control the production system using the various sensors. It is used for inspection and correction of the produced products. Next is maintenance purposes. So in this process, it starts with identifying the impact of state of change upstream and downstream processes of production system. It integrates, manages, and analyzes the machinery or process data during different stages of maintenance life cycle to handle data information more efficiently, and further achieve better transparency of machine health conditions. Production layout planning. Uh, Digital twin can be used to more efficiently construct continuous and simultaneous production layouts. Uh, with help of simulation, uh, we can accurately plan a layout so that it increases the efficiency of production. For production purposes, uh, the digital twin can be used here for motion data motion data generation and production. It's for the purpose of tracking the products in real time. Previously, for motion data, the technology which was used was radio frequency identification, but this technology is too costly to use. Using digital twin, uh, we don't need such technology. We can know the real time location and the status and position of the physical product. So the next point is cyber physical production system. Cyber physical production system is one of the main core components of Industry 4.2. Digital twin has enabled a production system to be centralized and have full control of the production process.
Sorry to interrupt. You have exceeding 10 minutes. So
okay. I'll briefly show the digital twin in current industry. The companies which are currently using the digital twin technology and for these applications. I'll skip over it. The advantages of digital twin are high quality prediction, optimization, visualization, advanced testing without actually making the prototypes, system integration, and remote handling. We don't actually have to be present at the production site to actually handle the machinery. The challenges for the future or limitations. Since it's a new technology, the expertise in this technology is very less currently. But as the technology grows, this limitation can be eliminated. Due to no proper standards, the cost of the projects is very high. The trust, since the companies don't have their own expertise of the this technology, they outsource it to other companies, but they don't trust the other companies to actually handle the data of their company. Then there are security issues, since it's a IT, since all the data is transferred through the cloud, and the data in IT infrastructure. So in conclusion, we have seen the enabling technologies for Industry 4.0 and digital twin, how it's one of the main core technologies for upcoming ongoing industrial revolution. In 2021, digital twin is used in a wide range of industries to increase efficiency of work. The technology is exclusive to manufacturing industry, but it's also used in many other industries like services and medical industry. So since every technology has its own sets of limitations, this technology also has, but since it's a relatively new technology, these limitations can be eliminated in the future. with further research. Thank you.
Thank you, Yash, for your presentation. It would have been appreciated if you would have done and contributed with respect to results and rather and your work with respect to digital twin or interaction with this a simple flow charts of yours rather than general this one. I didn't see much of your contribution over here with and it was kind of survey paper. So I request you to kindly work on this, and it's a good technology, upcoming technology, very much needed physical and real world interaction. And many mechanical engineers over here, professors here, will agree with you that the world is moving towards the digital twin, and a lot of researchers are there, right? You can and a good scope for one to improve.
Thank you for
Thank you.